Hey guys, tonight we hover in that deliciously impossible place above the moon, where everything feels both close enough to touch and impossibly ancient. And below you, the familiar silver coin begins to turn into something stranger, because the side facing Earth is only half the story, the polite public face, while the other half waits just out of sight like a shy genius at a party who absolutely refuses to make eye contact with your telescope. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And while you settle in, tell me your location and your local time down in the comments, because there is something oddly comforting about knowing where on Earth everyone is listening from while we hang together above a world that keeps one secret cheek turned away. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. You're looking at the moon the way most humans have always looked at it, with a kind of casual overconfidence, as if seeing the same face forever somehow means you know the whole person. But the moon has been running the same quiet trick on Earth for billions of years, and it is such an elegant trick that people wrapped it in mystery and gave it a dramatic name, the dark side, which sounds wonderfully spooky, like a place where moonbeams go to brood and write poetry in black turtlenecks. The truth is gentler and somehow more beautiful. The far side of the moon is not permanently dark at all. It gets sunlight, plenty of it. It has mornings, it has noon, it has long cold nights, and then it has dawn again. It is hidden from Earth, not hidden from the sun. That small correction changes the entire mood of the story. The far side is not some cursed lunar basement where light forgot its keys. It is simply the hemisphere that does not face you, because the moon rotates in a very particular rhythm. If you watch from space with the patience of stone, you would notice something that feels almost magical the first time it clicks. The moon turns on its axis at exactly the same rate that it travels around Earth. One full rotation for one full orbit. The timing matches so neatly that the same hemisphere keeps facing Earth almost all the time, as though the moon were a dancer trained to present one shoulder to a single audience forever. You can picture it without needing equations, which is a relief because equations at bedtime can feel a bit like being chased by a polite spreadsheet. Imagine walking in a circle around a table while always keeping your face turned toward a teacup in the center. To do that, you cannot just slide sideways like a haunted crab. You have to slowly turn your body as you move. By the time you complete one lap, you have also completed one full turn. That is what the moon is doing with Earth. It orbits and rotates together in a perfect cosmic compromise. This is called tidal locking, which sounds either very romantic or mildly threatening, depending on your mood. But it simply means gravity has trained the moon into a stable habit over immense stretches of time. Long ago, the moon probably spun faster. Young worlds are rarely calm. They wobble, flex, heat up, cool down, and generally behave like celestial toddlers with too much energy. Earth's gravity pulled more strongly on the nearer side of the moon than on the farther side, raising tidal bulges in the moon's body, slowly draining rotational energy away as heat. Over ages so long they make your longest Monday look brief and adorable. The moon's spin slowed until it settled into this locked state. Not by accident, not by design, just by gravity being patient in the most intimidating way possible. So from Earth, you see one hemisphere so consistently that it feels like the whole moon. Ancient sky watchers memorized its dark plains and bright rays. Lovers wrote poems to it. Farmers timed things by it. Children found faces and rabbits in it. Nobody standing on Earth, no matter how wistful or dramatic, could naturally see the far side. That hidden hemisphere stayed hidden because the moon kept turning at just the right rate to deny you the view. Not rudely, almost elegantly, like a velvet curtain that never jerks, only hangs there, unwavering. And yet, even this is not quite absolute. The moon is faithful, but not perfectly rigid. It nods a little. It rocks. It seems to tilt and sway over the course of its orbit because of the slight eccentricity of that orbit and the tilt of its axis. This gentle wobbling is called libration, and it lets you peek a little around the edges. Over time, from Earth, you can actually see about 59% of the lunar surface, not just 50. The moon gives you a little extra, like a host who says they are only serving tea and then quietly brings out cake. But the central far side remains out of view, permanently beyond any direct glance from Earth's surface. That hiddenness is where so much of the fascination comes from. Humans are very easy to enchant when told that something nearby has a face we have never seen. A mountain with an unseen valley, a house with a locked room, a person who smiles without explaining themselves. The moon is close enough to dominate the night and distant enough to remain untouchable, and that combination is irresistible. For most of human history, the far side was a blank in the imagination. People could project anything onto it. Silence, monsters, gods, cities, probably one or two deeply unnecessary prophecies. The actual far side, when finally revealed, turned out to be lovelier than all of that theatrical nonsense. But for now, hovering here in the calm black above the orbit, what matters is the basic tenderness of the mechanism. It hides not because it is dark, but because it keeps one face toward home. And still, the phrase dark side survives because language loves drama and is often unwilling to surrender a good line just because science gently clears its throat. The far side does experience darkness, but only in the same normal way every place without a permanent nearby sun does. Day follows night. Night follows day. The moon's day is just astonishingly slow. Because the moon orbits Earth while Earth and moon both travel around the sun, the cycle from one lunar sunrise to the next lasts about 29.5 Earth days. So any one place on the moon gets roughly 2 weeks of daylight, followed by roughly 2 weeks of darkness. Not eternal night, just a very committed version of evening. You can imagine standing on that hidden hemisphere and watching the sun crawl through the black sky with patient grandeur. The sunlight would not feel rushed. Shadows would lengthen almost imperceptibly. Rocks would warm for days. Then the long night would settle in and the stars would return with terrifying clarity. It would be dark, yes, but only as part of the same cycle shared by the near side. The far side is not denied the sun, it is denied Earth. That distinction is everything. If you stood on the near side, Earth would hang in the lunar sky, big and blue and white, almost motionless except for tiny shifts. But on the far side, Earth would never rise, never set, never appear at all. That missing Earth would make the sky feel larger and lonelier, though perhaps also purer, like a room after someone finally stops talking. The hidden hemisphere is not the dark side in terms of light. It is the earthless side, the no home in the sky side, the place where the moon keeps all of space in front of it and all of Earth behind its back. You might think that means the far side is somehow colder in spirit, but there's another way to feel it. The near side is the face the moon offers to relationship, the side in constant visual conversation with Earth. The far side is the face it keeps for itself. Every world, if it is allowed enough time, develops a private half. And that private half can be just as sunlit, just as real, just as textured with dawn and dusk as the face shown outward. There's something deeply soothing in that. Not every hidden thing is sinister. Some things are hidden simply because of how they move through love and gravity. It is lovely, too, that the moon's secrecy is not active. It is passive, almost sleepy. No effort, no drama, just a steady lockstep motion, so reliable that human culture has built calendars around it. Somewhere in that reliability is the beginning of trust. You can step outside tonight and know exactly which face the moon is showing you. You can know that the other face is also there, turning through its own day and night, not erased, not cursed, not waiting in blackness for some cinematic violin sting. It is merely elsewhere, and that elsewhere has always had power over the mind. The far side became a symbol because it sits at the edge of the visible while staying physically near. It is a reminder that intimacy does not equal total knowledge. Even your closest celestial neighbor has a hidden half. Even the moon, that old dependable lantern, keeps something beyond direct sight. You do not have to fear that fact. You can rest in it. Mystery does not always demand solving. Sometimes it only asks to be noticed. So you remain here above the moon a little longer, watching the locked ballet continue, orbit and rotation braided into one silent motion, and you let the old phrase soften your thoughts. Not dark side, far side, not a place abandoned by light, but a place withheld from one particular point of view. A difference so simple it almost feels disappointing at first, until you realize how much gentler the universe often is than the myths we write for it. Gravity did not build a haunted hemisphere. It built a rhythm. The moon learned the rhythm and never forgot it. And somewhere below, on that hidden face, sunlight is touching stone right now. That sunlight touching stone does not hurry. And that is where the hidden hemisphere becomes almost absurdly relaxing, because the far side of the moon lives by a schedule so slow that your most delayed train, your most unread email, your most dramatic promise to start being productive on Monday all shrink into tiny, embarrassed little blips. On Earth, sunrise is a daily event, dependable and brisk enough that people spill coffee, curse alarms, and miss it while searching for a sock. On the moon, sunrise behaves like a grand aristocrat descending a staircase, one measured step at a time, entirely unbothered by your preferences, your planner, or the concept of getting on with it. If you were standing on the far side at the edge of night, the sun would not suddenly leap up and brighten everything in a cinematic burst. It would creep. It would take its time. A low rim of light would begin to gather along the horizon, and the shadows of rocks would stretch across the ground like long, dark thoughts. Hours would pass, and the light would still be arriving. Days would pass, and morning would still be unfolding. The moon rotates so slowly relative to the sun that a full cycle from sunrise to sunrise lasts about 29.5 Earth days. So one lunar day, the whole sequence of dawn, day, dusk, and night takes nearly a month of our time. That means the daylight portion alone lasts roughly 2 Earth weeks. 2 weeks of the sun climbing, arcing, and descending with stately indifference. Then about 2 weeks of night. Not because the far side is special in that respect, but because the entire moon participates in this ridiculous luxury of time. Still, the far side feels it differently in the imagination, because there is no Earth in its sky to keep it company. Just sunlight arriving at a glacial pace, and darkness leaving just as slowly, as if the whole place were determined to resist any emotional overreaction. Imagine how different that would make everything feel. On Earth, light changes quickly enough that you barely notice the motion until suddenly the room is dim or suddenly the window is gold. You live inside fast transitions. The moon gives you transitions so extended they become landscapes in themselves. Dawn is not a moment. Dawn is an era. Noon is not a sharp event. It is a long, silent occupation. Sunset is not a flare and a fade. It is a patient retreat that can keep a crater rim glowing for what would feel, to you, like a lifetime of unhurried evenings. The pace changes not just the mood, but the physics of the surface. Lunar soil and rock, baked by direct sunlight, with no atmosphere to soften or scatter the heat, warm up under this long day and cool down through the equally long night in extremes that Earth rarely allows. Daytime temperatures near the equator can climb well above the boiling point of water, if water were foolish enough to try being liquid there in open sunlight. Nighttime temperatures can plunge to astonishing cold, the kind of cold that makes ordinary winter look like a mildly impolite breeze. The moon does not do gentle weather. It does not have weather at all, which is in some ways very efficient and in other ways quite rude. And because there is no substantial atmosphere, the dawn on the far side would not bloom in the way dawn blooms on Earth. No pink veil, no blue wash, no clouds catching fire like slow-moving theater curtains. The lunar sky stays black even in full day. That alone is enough to make the place feel like a dream someone had after reading too much astronomy and then falling asleep under a weighted blanket. The sun rises into a black sky. The land brightens without the air ever joining in. There is no bird song, no wind in grasses, no rustle, no haze. Just sharp light, black above, gray below, and shadows so dark and clean they look cut with a knife. Those shadows would be extraordinary. On Earth, air and scattered light soften edges. Shadows are tinted, interrupted, diluted by atmosphere. On the moon, especially under a low sun during those long dawn and dusk periods, shadows can seem almost solid. A boulder throws a darkness that looks like an object in its own right. Crater walls divide the land into zones of brilliance and blackness with almost theatrical precision. But unlike a theater, nothing is rushing toward the next cue. The spotlight lingers. The stage remains set for days. You could spend an entire Earth afternoon watching a single shadow slowly pivot across the floor of a crater and feel as though you were witnessing the universe remember how to breathe. That is one of the most relaxing facts about the far side, strangely enough. Not that it is tranquil in a cozy cottage sort of way. It is tranquil in a cosmic way, an enormous indifference that becomes soothing once you stop expecting it to entertain you. The moon has no schedule except motion, no clock except orbit, no urgency except the one humans keep trying to drag there in little metal boxes. And if you stayed through noon, you would find that even the peak of day refuses drama. Sunlight would come from above more directly, shadows shorter now, surfaces glaring with hard brightness. The ground would be warm, then hot, then punishingly hot in exposed places, but visually the scene would remain austere, stripped of all the earthly flourishes that atmosphere provides. No blue dome, no drifting white cloud to break the monotony. No dragon-shaped puff for you to pretend means something. Just the sun, the black sky, and a silence so complete it almost counts as architecture. It is tempting to think that such slowness would feel boring, but boredom is often just speed withdrawal. Earth trains you to expect constant variation. Notifications, traffic lights, conversations, background hum, weather fronts, little changes stacked on top of little changes until your nervous system starts acting like a squirrel with a coffee habit. The far side offers the opposite. It asks whether you can remain with one change long enough to actually feel it. The slow lifting of sunlight, the gradual warming of rock, the lengthening and shrinking of shadows over spans so wide that impatience eventually gives up and wanders off. And then, just when you have adjusted to that long day, the evening begins. Again, not all at once. The sun lowers, but lowering is a very leisurely business here. The same crater rims that once caught the first light now hold the last of it, glowing while the basin floors sink into black. High points remain illuminated, while low places are already night. The land becomes a map of fading gold and advancing darkness. Except without air, the gold is not really gold, not in the earthly sense, more harsh white brilliance tilting into gray. Still, your human mind will color it emotionally. Evening always gets a little poetic, even when the moon is being brutally literal. One by one, features disappear into shadow. The cold returns, not with a gust because there is no wind to perform for you, but with radiative honesty. Heat leaves, surfaces cool, darkness takes over. Then begins the long lunar night, another stretch of roughly 2 Earth weeks, and the far side becomes what people lazily imagine it always was: black, frozen, starlit. Except even now, it is not the dark side in any permanent or cursed sense. It is simply its turn. That phrase matters because there is something deeply comforting in knowing that the far side is not trapped in darkness. It participates in a cycle, and cycles are among the universe's gentlest truths. Night arrives, but it leaves. Light departs, but it returns. The moon keeps this promise with almost absurd regularity, just at a pace that makes human impatience look very provincial. You can almost hear the far side saying, in the driest possible tone, "Yes, of course the sun comes back. It is just not my fault you creatures insist on measuring everything in business days." The slowness also changes how you imagine being there. On Earth, travel and work are planned around daily light. Morning tasks, afternoon light, evening rest. On the moon, especially on the far side where Earth never hangs above to offer psychological companionship, the timing of activity becomes something more deliberate. Machines must survive savage cold and harsh heat. Solar power means feast and famine in long chapters. Every sunrise is a logistical event. Every night is a test of endurance. And somehow that makes the place even more serene to think about, because nothing casual survives there. Everything must be patient, prepared, and humble before the calendar of light. You may notice how this hidden hemisphere keeps gently rearranging your sense of time. First, it corrected the myth of permanent darkness. Now it stretches the simple idea of day until it feels almost ceremonial. On the far side, the sun does not merely rise. It arrives after a long negotiation with orbital mechanics. It does not merely set. It withdraws like royalty, leaving a room full of stunned courtiers. Even the ground seems to understand the tempo, holding heat, releasing heat, enduring these long occupations of light and night without complaint. And because the sky stays black, stars can appear in ways your instincts find strange. During the day, the glare of the sun on the surface and in your visor would dominate your view, but the sky itself would not turn blue. At night, without atmosphere and without Earth in the far side sky, the star field would feel especially remote and severe. The contrast between the long glaring day and the long frozen night would be total. Yet the transitions between them would be slow enough to ease the mind into each state. The moon, in this one small way, is a master of pacing. So you stay a little longer in that imagined place near the horizon of the far side. Watching dawn take forever, watching noon refuse spectacle, watching dusk spread its patient black fingers over crater and ridge, and it becomes impossible not to admire the sheer composure of it. Earth spins fast, chatters endlessly, and hurls you from one hour to the next. The far side keeps its own counsel. It lets a sunrise last longer than some vacations. It lets night settle in so gradually that resistance seems silly. And somewhere within that enormous, silent schedule, the hidden hemisphere becomes less like a secret and more like a lesson in how slowly beauty can move when nothing interrupts it. That patience of light leaves marks, and the far side wears them with almost unreasonable composure. Once you have watched the sun spend days climbing over a single horizon, the land below begins to reveal why it feels so different from the familiar face of the moon you know from Earth. The near side has those broad dark patches that even ancient sky watchers noticed, the so-called seas, though they are not seas at all, just vast plains of ancient volcanic basalt cooled into smoother, darker expanses. The far side, by contrast, looks rougher, brighter, more crowded with old wounds. It is a place of highlands and scars, pitted and layered and quietly magnificent, as if time did not merely pass over it, but sat down and engraved itself there with obsessive care. From above, the first impression is density. Craters crowd one another in a way that makes the surface feel ancient before you even know any geology. Small craters overlap large ones. Large craters interrupt older structures. Rims are broken, softened, recut. You do not see neat simplicity. You see a palimpsest, a surface written over and over and over again, each impact leaving its paragraph, each billion years adding footnotes in stone. It would be chaotic if it were not so still. But because nothing moves quickly there now, the far side presents all this damage with the calm of a museum. Violence happened. Silence kept the record. And the record is old. Very old. Much of the far side consists of lunar highlands formed early in the moon's history. Made mostly of lighter-colored anorthositic crust, ancient material dating back toward the beginning, when the young moon was cooling from a far more molten past. Those highlands preserve the memory of an era called the Heavy Bombardment, when the inner solar system was a much messier place and worlds were hit again and again by large bodies left over from planetary formation. On the far side, the evidence is not smoothed into broad dark plains as often as on the near side, so the old impacts remain more legible. It is like comparing two old manuscripts, one heavily edited and recopied, the other left with all the original marginalia and scorch marks intact. That is one reason the far side feels older at a glance. Not because it literally formed in a different century, which would be a very charmingly human misunderstanding of a 4.5 billion-year-old object, but because its ancient terrain remains exposed. You're seeing crust that kept more of its early character. The heavy volcanic flooding that created the Dark Maria on the near side was far less extensive here, so fewer large areas were resurfaced by later lava. The result is a hemisphere that still looks battered in the old style, with high-standing crust and cratered expanses that reach back toward the moon's first long chapters. The serenity comes from that age. Old landscapes have a different emotional texture than young ones. A young volcanic plain can feel bold, efficient, declarative. An old cratered highland feels patient, resigned, almost wise if you are in the mood to be gently sentimental about rocks, which tonight you absolutely should be. Every crater on the far side says the same quiet thing in a different accent. Something happened here a very long time ago, and then enough time passed for the violence to become geometry. There is a strange comfort in the geometry. Impact craters are born in chaos, but they often settle into forms so orderly they feel designed. A circular rim, terraced walls and larger impacts. Central peaks, where the crust rebounded like a struck drum skin frozen mid-bounce. Ejecta thrown outward in bright radial patterns, later softened by tiny impacts and the relentless gardening of micrometeorites. On the far side, these forms repeat across enormous distances, not monotonously, but rhythmically. Crater after crater, each one a variation on a cosmic event, and yet together they create a kind of visual lullaby. Rings within rings, basins within highlands, raised rims catching light, shadowed floors preserving night a little longer than the surrounding plain. If you drift lower over the far side, the brightness of the highlands becomes more striking. From Earth, the near side's Dark Maria create the familiar face-like pattern. The far side lacks that visual shorthand. It does not present itself in easy patches of contrast that invite folklore. It is brighter overall because those lighter highland materials dominate. But brighter does not mean smoother. Quite the opposite. Under low sunlight, especially in the long dawn and dusk you have already lingered in, every ridge and crater lip throws a shadow. The land becomes a field of relief, all texture, all memory, all surface detail insisting on being noticed. And because the far side has so many overlapping old craters, it can look busy from orbit and empty from the ground at the same time. That sounds contradictory, but the moon enjoys that kind of contradiction. From above, the terrain is crowded with structures. From the surface, you might stand inside one crater while another rim sits on the horizon, with dozens more too large or too worn to declare themselves immediately. The age of the landscape becomes scale-dependent. Some scars are so vast you can only understand them from orbit. Others are small enough to cup in shadow at your feet. Everywhere you look, there is evidence that the surface has been exposed for a very long time, taking hit after hit, then simply remaining. That remaining is part of the relaxation. On Earth, erosion is busy. Wind rounds mountains. Rain cuts valleys. Rivers rearrange sediment with endless fussy determination. Glaciers scrape. Plants pry open rock and turn it into soil. The landscape is always in conversation with water and air. The moon has none of that. No rain, no rivers, no roots with ambitions. Once a crater forms, it can persist for immense spans, modified mainly by later impacts, and the slow, pulverizing work of tiny particles. The far side, therefore, keeps its old stories visible in a way Earth almost never can. An ancient wound on Earth is usually disguised by geology's housekeeping. On the Moon, especially here, it remains on display with very little editing. So when you look across the far side, you're not just seeing a rougher hemisphere. You're seeing one that has had fewer chances to cover its tracks. Its history sits closer to the surface. It is a little like meeting someone who never learned to hide their expression. Not dramatic, not confessional, simply transparent in a way that feels disarming. The Moon's familiar face, the near side, has those dark maria that soften the pattern and create spacious visual rests. The far side is more densely annotated. It offers fewer large blank pages. Every patch seems to have a story scratched into it. There's also something noble about how quiet those stories have become. Each crater was once an event of unimaginable force. Rock vaporized, shock waves tore through crust, debris flew, heat surged. Entire local landscapes were remade in moments. Yet now, under the slow crawl of lunar daylight, they are just landforms. The rim of one crater catches dawn and looks almost delicate. A central peak stands in shadow like a folded thought. The floor of another lies flat and still. Catastrophe matures into scenery. That is a very lunar kind of grace. And the far side gives you more of that grace because its surface is older in appearance and more extensively cratered. In many places, new impacts did not erase the old so much as converse with them. A small, fresh crater punches into the floor of a giant ancient basin. A chain of secondary craters arcs away from a larger impact site. Worn rims are ghosted beneath newer structures. Some craters are crisp, with sharp edges and bright ejecta, while others are softened almost into memory. Their outlines faded, but still legible if the sun is low enough to be sympathetic. The whole hemisphere feels like an archive in which some pages are pristine, others foxed and torn, and none have been thrown away. This is why the far side can seem more serene than the near side, even though it is objectively more battered. The near side's dark plains are dramatic and beautiful, but they speak of later resurfacing, of change that smoothed and covered and reset large regions. The far side lets antiquity show. It is rough in a restful way, if that makes sense. The way an old stone wall can feel more calming than newly painted one because every chip and irregularity promises endurance. Perfection is tense, whereas easier on the nerves. It also helps that the far side has less of the face-like familiarity that humans tend to project onto the near side. We see patterns there because contrast invites imagination. The far side resists casual anthropomorphism. It does not offer an easy face or rabbit or man-in-the-moon expression. It offers terrain instead. Pur terrain. Highlands, craters, basins, ridges. In that sense, it can feel more honest. As though the moon, when no one is looking from Earth, allows itself to be geological rather than symbolic. So you continue across these battered highlands, following the long shadows from one old rim to the next, and the surface starts to feel less damaged than weathered, less wounded than inscribed. The craters are not just impacts anymore. They are clocks without hands, telling age by accumulation and overlap. The highlands are not just bright crust. They are ancient pages left mostly unrewritten. The far side serenity is not the serenity of untouched perfection. It is the serenity of survival, of a place that has been struck, marked, exposed, and then allowed to rest for eons under a black sky. And as you watch that slow sunlight move over the rough white-gray land, another question begins to gather at the horizon of your thoughts. Why did this hidden hemisphere keep so much of its old crustal story visible, while the near side ended up with those broad dark plains? Why is one face more heavily scarred and less flooded with ancient lava than the other? The answer lies deeper than the craters themselves, in the very thickness of the moon's crust, where the far side turns out to have kept not just its secrets, but a structural difference that shaped the whole mood of its surface. That structural difference is one of the moon's most soothingly unfair little secrets. The far side did not simply end up rougher by chance, as though the universe flipped a coin and decided one hemisphere would get all the tidy dark planes while the other inherited the entire family collection of dents. Underneath that more battered surface lies a real asymmetry. The crust on the far side is, on average, thicker than the crust on the near side, and that single fact changes almost everything about the moon's personality. It changes how lava moved, how impacts reshaped the land, how the hidden hemisphere aged in public, and why one side became the moon of familiar dark blotches while the other kept its bright, cratered, highland-heavy austerity. You can think of the lunar crust as the moon's outer shell, the upper rocky layer that formed early as the young moon cooled, long before it became the calm, silent companion of Earth's night sky. The moon was a hotter and more dramatic place. It likely began with a global ocean of magma, because apparently even gentle bedtime topics sometimes start with a planet-scale cauldron. As that molten ocean cooled, lighter minerals floated upward and formed an early crust, rich in materials like plagioclase feldspar. Over time, this shell thickened and differentiated, but it did not end up the same everywhere. For reasons that scientists have worked hard to understand, the near side and far side developed a striking crustal imbalance. The near side crust is generally thinner. The far side crust is generally thicker. Not impossibly thicker, not cartoonishly so, but enough to matter in every major way that geology knows how to be dramatic while pretending it is just being factual. When enormous impacts slammed into the moon and internal heat tried to push magma upward, the thinner near-side crust was easier to crack, easier to penetrate, easier to flood. The thicker far-side crust was more resistant, less permissive, more of a stern gatekeeper. Lava knocked, and the far side often said, in effect, absolutely not. That is why the near side acquired so many Maria, those dark basaltic plains that ancient observers mistook for seas. Large impacts created basins, and later volcanic eruptions flooded many of them with dark lava. The result was a surface with broad, smooth, darker regions that softened the old crater record and gave the moon its familiar face from Earth. On the far side, large impact basins existed too, but widespread lava flooding was much less common. The thicker crust made it harder for magma from below to reach the surface in the same abundant way. So many far-side basins remained highland-dominated, brighter, rougher, and older-looking. This makes the far side feel like a lunar version of restraint, not because it lacked drama in its history. It had plenty. It was hit, fractured, uplifted, buried in ejecta, shaken by impacts, and altered by internal processes just like the near side. But its crust acted like a stricter editor. It allowed less of the dark volcanic rewriting that transformed so much of the near side. As a result, the hidden hemisphere preserved more of its original crustal character. It stayed wider, higher, and more heavily cratered in appearance, not because it escaped history, but because one layer beneath the surface shaped how that history could show itself. There's something wonderfully calming about this. A difference of thickness, a small structural bias, carried through billions of years until it became visible even in the moon's expression. You're seeing geology with a personality, though of course geology would hate that phrasing and insist it has no personality whatsoever, while standing there in a very obvious mood. The far side's mood comes partly from what it refused to become. It did not develop Maria on the same scale. It did not let lava spread as generously over its old scars. It kept its highlands exposed. It held on to brightness where the near side darkened. And once you know this, the whole hemisphere starts to look less random. The ruggedness makes sense. The brightness makes sense. The density of visible old crust makes sense. The far side is not merely the more battered half. It is the half whose crust more often kept the door closed. That simple refusal shaped the entire visual texture of the landscape. When dawn crawls across the far side, it catches countless ridges and crater rims because so much of the old highland topography still dominates. When sunlight falls across the near side, it also crosses vast, smoother basalt plains that tell a different story, a story of lava surfacing and settling over older wounds. How did this asymmetry happen in the first place? That is one of the moon's tastier scientific questions, because the answer is not just one neat sentence with a bow on top. Several ideas help explain it, and together they suggest that the moon's early thermal and chemical history was lopsided. One possibility involves how heat-producing elements became distributed inside the moon. The near side seems to have been richer in certain materials associated with internal heating and volcanic activity, especially in regions tied to a geochemical province, sometimes called KREP, an acronym so gloriously inelegant that only geology could love it. These components include potassium, rare earth elements, and phosphorus, and their concentration on the near side may have helped keep that hemisphere warmer for longer, encouraging melting and volcanism. Another factor may have been the thermal influence of Earth itself during the moon's earliest history. When the moon formed and orbited closer to Earth, the near side may have experienced different cooling conditions than the far side. Earth, still hot and glowing in the aftermath of formation, may have affected temperature gradients across the young moon. The far side could have cooled differently, allowing a thicker crust to build there as material accumulated or solidified under different conditions. The details are still debated and refined because the universe rarely hands over its paperwork in neat folders. But the broad outcome is clear enough. The moon froze into asymmetry, and that asymmetry lasted. You do not have to memorize the chemistry to feel the consequence. It is visible in the landscapes themselves. The far side is more highland-heavy because thick crust and less extensive volcanism kept ancient anorthositic terrains dominant. Its cratered appearance is not just a record of impacts. It is also a record of what did not happen afterward. No great basalt floods smoothing everything into wide dark sheets on the same scale. No comparable repainting. The older script remained legible. In a sense, the far side is geology by omission as much as geology by action. That idea is unexpectedly restful. On Earth, your mind is often pulled toward what happened, what changed, what arrived in a burst and left a mark. The far side invites you to consider the quiet power of prevented change. A thicker crust said no, repeatedly over deep time. No, not as much lava here. No, not that much resurfacing. No, let the old terrain remain. And because of those countless geological no's, the far side became the moon's bright old archive instead of its smoother volcanic gallery. It also explains why the far side feels less immediately familiar to the human eye. You evolved under a sky where the near side's dark Maria offered strong contrast and memorable patterns. The hidden hemisphere lacks that layout because the darker basaltic plains are scarcer and smaller overall. You see more uniform, light-toned crust, more high-relief terrain, more complicated crater overlap, fewer restful, dark expanses. It is less face-like and more topographic. Less folklore, more memory. Less icon, more document. And what a document it is. The thicker crust allowed the far side to preserve ancient highlands, but also changed how impacts express themselves. When large asteroids or comets struck, they excavated the crust and reshaped local terrain, yet the aftermath did not as often become filled by later lava. So impact basins remain more obviously basins in bright crustal terrain rather than dark Maria. The contrast between crater and plain stayed sharper in some places. Relief remained more pronounced. Surface history stayed closer to the top. The far side, by keeping its crust thick, kept its architecture. You can almost imagine the moon being built from two moods. One side thinner-skinned, warmer inside, more volcanically forthcoming. The other side thicker-skinned, more reserved, more inclined to keep the original surface visible. Not opposites exactly, more like siblings with very different coping mechanisms. The near side says, yes, something terrible happened here, but then lava came and rearranged the furniture. The far side says, yes, something terrible happened here, and here is the exact rim where it happened, still in place after all this time. Both are beautiful. Only one is better at pretending it moved on. And because the far side is the side you cannot see from Earth, that structural reserve takes on a poetic flavor whether science asks for that or not. The hidden hemisphere turns out not only to face away from you, but also to have developed a sturdier shell. It is literally more heavily crusted, more guarded, less easily breached by upwelling magma. The metaphor practically writes itself, though the moon would probably prefer we keep this professional. Still, there is comfort in the coincidence. The side that stays private is also the side that held onto its older self more firmly. So you glide onward above the far side and let this deeper story settle in. The battered bright highlands are not just scenery. They are the visible consequence of crustal thickness, internal heat, ancient chemistry, and a long selective permission of volcanic change. Beneath every cratered plain is a structural choice made by the moon's early history. The hidden half became rougher, brighter, and more ancient-looking because its shell was harder to break through. The landscape you see is, in part, the shape of resistance. And soon that resistance leads your eye toward one of the grandest features anywhere on the moon, a place where impact and crust and deep history meet on a scale so enormous it almost stops feeling like geography and starts feeling like myth carved into rock. That scale is almost rude. The moon has many craters, many basins, many rings and scars laid down by a solar system that clearly went through a phase of throwing rocks at everything in sight. But then you come to the South Pole, Aitken Basin, and all your normal habits of description begin to fail in a very sleepy, respectful way. Large stops being useful. Ancient becomes obvious to the point of laziness. Even colossal starts sounding like it is trying much too hard. What lies across the far side, stretching from the lunar South Polar region deep toward the far hemisphere, is one of the biggest impact basins in the entire solar system, a wound so vast that it has long since stopped behaving like a simple crater and started acting like a piece of planetary identity. If you were high above the moon and someone did not point it out, you might not grasp it immediately, which is part of the basin's strange dignity. Small craters announce themselves. Medium craters are crisp, circular declarations. But a feature this immense is too big to fit inside ordinary intuition. It spans roughly 2,500 kilometers across, give or take depending on how you trace its boundaries, and it reaches great depths compared with surrounding terrain. Its shape is ancient, weathered by later impacts, softened in places by time and overprinting. But the basin remains there in the moon's structure like a deep note that continues, sounding long after the strike that created it has faded. To appreciate it, you almost have to stop thinking like a tourist and start thinking like gravity. The South Pole, Aitken Basin, is not a scenic pothole. It is a planetary-scale excavation. Long ago, early in lunar history, a massive impactor slammed into the moon with such energy that crust was shattered. Material was blasted outward across enormous distances, and the local architecture of the far side was remade in one catastrophic event. Mountains rose around portions of the rim. Deep layers were exposed or disrupted. The basin floor settled lower than the surrounding terrain. Everything about it says that the moon's early history was not a gentle drifting into place, but a violent assembly followed by an unimaginably long recovery. And yet recovery is exactly what the basin now conveys. The violence is over. What remains is grandeur. That is one of the most relaxing facts about this place, oddly enough. The South Pole, Aitken Basin, was born in a blow that would have defied any human scale of disaster, but because billions of years have passed since then, it no longer feels like an event. It feels like a landscape, catastrophe has matured into silence. The basin holds its history not as panic, but as form. You can float above it and feel not fear, but all with the edges sanded down into calm. Its name is wonderfully practical, in that endearing scientific way that suggests no one in the naming meeting was willing to risk poetry. South Pole, Aitken. One edge near the South Pole, the other extending toward Aitken Crater. Efficient, solid, slightly like naming a dragon after 2 bus stops. But the plainness of the name does something useful. It keeps your attention on the basin itself, on the actual immensity of the feature, rather than dressing it up with mythology it does not need. Some things are already so grand that adding theatricality only makes them smaller. The basin matters scientifically because impacts of this size can punch deep into a world's crust, perhaps even affecting the mantle below. When researchers study the South Pole, Aitken Basin, they're not just admiring a huge scar. They're looking at one of the best opportunities to understand the moon's deep interior, its early crust, and the mechanics of giant impacts that shaped rocky bodies throughout the solar system. The basin may have brought up material from depths usually hidden from view, or at least altered the crust in ways that preserve clues about what lies below. In other words, this ancient impact did not merely damage the moon. It opened a window. That window, though, is not a tidy glass rectangle with explanatory labels and a gift shop. It is a battered, overlapping, partially obscured geological revelation spread across a hemisphere. Later craters formed inside it. Ejecta from other impacts landed on it. Time complicated its boundaries. Some parts are easy to identify in topography and composition, others less so at a glance. It is a basin you understand better the longer you look, which feels appropriate for a place on the far side. Hidden things should reward patience. The moon is consistent about that, and patience is exactly what this basin invites. If you imagine crossing it in those long days of lunar sunlight, you would not experience it as one neat bowl. You would move through terrains that rise and fall, ancient crater floors, subdued rings, local high points, and lower expanses whose meaning only emerges fully from orbit. The South Pole, Aitken Basin, is so large that standing inside, it can feel like standing inside history without realizing the walls are all around you. The horizon would not announce, "Congratulations, you are now in one of the solar system's largest impact structures." It would simply continue, gray and old and cratered, while the deeper truth waited in the shape of the land beneath your feet. That is part of what makes it relaxing to contemplate. It is a grand feature that does not show off. It does not need to. Unlike a mountain stabbing into the sky, the basin's greatness is subtle from ground level and overwhelming from the right perspective. It teaches scale gently, by letting you discover that what seemed like ordinary rugged lunar terrain is actually the softened interior of a structure vast enough to alter the moon's own geological story. There is no rush in that lesson. No dazzling, just the slow arrival of understanding, which, as you may have noticed by now, is one of the far side specialties. The basin's age adds another layer of calm. It is ancient enough that it likely formed more than 4 billion years ago, back in the rough early era, when the inner solar system was still dealing with leftover debris and impact rates were far higher than today. That means the South Pole, Aitken Basin, has existed for almost the entire known history of the moon as a solid body. It has spent eons under black skies, beneath long sunrises, absorbing micrometeorite dust, watching later craters appear and soften. If a place can become wise through sheer duration, this one qualifies. There's also something wonderfully humbling in the idea that one of the greatest impact basins in the solar system sat hidden from direct human view for all of recorded history. Humanity watched the moon constantly, named patterns on its near side, built myths out of its changing phases, used it to mark months and tides and longing, and all the while this immense structure existed just around the curve, unseen from Earth, not concealed by intention. simply placed on the wrong side of a tidally locked world. The biggest room in the house was there the whole time, and no one could look through the door until machines learned to go for us. And what a room it is! The South Pole, Aitken Basin, anchors the far side with a sense of depth that is both physical and emotional. Physical, because its topography lies lower than surrounding highlands and preserves a history of excavation on an enormous scale. Emotional, because it changes how you feel about the hidden hemisphere. This is not just the rougher side, not just the older-looking side. It is the side that holds one of the moon's deepest memories, a memory so large it bends the whole mood of the landscape toward grandeur. You can almost feel that grandeur in the way later sunlight moves across it. Basin floors and inner structures catch dawn differently than surrounding heights. Long shadows spill from crater rims inside the basin. The low sun picks out subtle undulations, ancient terraces, and scars layered atop scars. Nothing glitters. Nothing chatters. The landscape does not plead for your attention. It simply receives light and returns it in contours. If the near sides Maria feel like broad statements, the South Pole, Aitken Basin, feels like a basso note held for billions of years. Some scientists hope this basin may tell us about more than the moon. Giant impacts were part of the architecture of the early solar system. Worlds were shaped, stripped, tilted, heated, and resurfaced by collisions. To study a giant basin this old and this well preserved is to study a kind of fossilized violence that belongs not just to one moon, but to the larger story of how rocky planets and moons settled into the quieter arrangements we know today. The South Pole, Aitken Basin, is not merely local scenery. It is a surviving record from the era when the neighborhood was far less civilized. But again, the basin's great gift is that all of this is cooled into peace. The event is gone. The energy dissipated billions of years ago. The dust settled long before Earth had forests, before there were mammals, before anything on our planet ever looked up and wondered. What remains now is the kind of stillness only deep time can produce. A stillness earned, if rock can be said to earn anything. A stillness with history in it. When you imagine floating over the basin, you are not witnessing destruction. You are witnessing the afterlife of destruction, which is often where beauty finally becomes visible. And because parts of the basin reach toward the lunar South Polar region, the story begins to brush against another kind of quiet, one even subtler than ancient impact topography. There are places near these polar latitudes where sunlight barely reaches, where crater interiors can remain permanently shadowed, where cold becomes less a weather condition and more a long-term state of being. The far side is already distant from Earth's gaze, and around these polar reaches, it becomes distant from ordinary sunlight too. The basin's grandeur starts to meet a colder, quieter frontier, and the hidden hemisphere grows more hushed still. Before that deeper hush arrives, though, you remain over the South Pole, Aitken Basin, a little longer, letting its impossible scale settle into you. A basin wider than countries, older than any earthly landscape in its present form, born in violence and preserved in silence. It is difficult to imagine a more lunar idea than that. A blow so large it should feel chaotic, and yet what you receive from it now is order, depth, and composure. The far side does that to everything. It takes the spectacular and lowers its voice until grandeur itself becomes restful. That restfulness becomes even stranger when you realize the far side is not only visually secluded. It is in one very precious scientific sense, sheltered from Earth's noise. Not noise in the ordinary bedtime sense, because of course ordinary sound has no chance out here. There is no air to carry a whisper, no breeze to gossip over a crater rim, no rustle of anything leafy because the moon has shown heroic commitment to never inventing leaves. What the far side offers instead is radio quiet. And that is one of the most relaxing facts about it. If you happen to enjoy the idea that the universe can still provide at least one room where humanity's endless broadcasting is politely put outside. Earth is loud, brilliantly alive, deeply charming, absolutely exhausting Earth. Even when you are asleep, the planet hums with transmissions. Radar, television, radio stations, satellites, communications links, navigation signals, military systems, scientific instruments, all of it spilling into the electromagnetic environment in layer upon layer of chatter. Your civilization cannot seem to stop talking. It sends out signals the way a campfire sends sparks, the way an anxious person sends follow-up messages beginning with just circling back. Most of the time, that noise is useful. Sometimes it is beautiful. But for radio astronomy, especially when you want to listen for the faintest whispers from the cosmos, Earth is a spectacularly inconsiderate neighbor. The far side of the moon has a rare gift. When you are there, with the moon's bulk between you and Earth, the lunar body itself blocks radio interference coming from our planet. It is physical shielding on a planetary scale, a whole moon acting like a do not disturb sign. Earth transmissions do not have a direct line through solid rock, so the hemisphere turned away is naturally protected from much of that radio clutter. It is one of the quietest places near Earth for listening to the universe in radio frequencies, especially the low frequencies that are otherwise so frustrating to observe from our busy planet. That shielding is not just a neat detail. It is extraordinary. On Earth, radio astronomers have to seek out remote deserts, protected zones, and carefully regulated areas to escape modern interference. And even then, the sky is never entirely free of human signatures. A plane passes overhead. A satellite crosses. Some distant transmitter misbehaves. Somewhere, somehow, a machine is being very proud of itself on a frequency you would rather it kept private. The far side removes a great deal of that problem in one elegant sweep. Hide behind the moon, and Earth goes quiet. You can feel the emotional beauty of that before you even get to the science. Imagine standing on the hidden hemisphere during lunar night. No Earth in the sky. No atmosphere overhead. No radio station beaming through. No constant electronic weather from the planet that made you. Just the black of space and the ancient surface beneath your boots, and around you the kind of quiet that is not merely the absence of sound but the absence of interruption. Not many places in the human story offer that. The far side does, simply by being where it is. It helps to make one little distinction here, because the moon is fond of them. Silence in ordinary language usually means no audible sound. In space, audible sound does not travel through vacuum in the way it travels through air. So every part of the moon is already silent to human ears unless something is physically touching you and vibrating through your suit or equipment. Radio quiet is different. It means freedom from radio frequency interference, the electromagnetic clutter that can drown out faint natural signals from the universe. The far side is not better because it is more soundless than the near side in any simple acoustic sense. It is better because it is more protected from Earth's technological babble. And the universe has a lot worth listening to if you can just get everyone else to stop talking over it. Radio waves come from all sorts of cosmic sources: the sun, planets, pulsars, distant galaxies, clouds of gas, energetic particles, and structures formed in the early universe. Some of the most interesting radio signals are incredibly faint by the time they reach us. Trying to detect them near Earth can be like trying to hear a pin drop while standing in the middle of 1,000 overlapping podcasts, 2 weather alerts, and an advertisement for wireless earbuds. The far side says, perhaps a bit smugly, there is another option. It is especially valuable for very low-frequency radio astronomy. Earth's ionosphere, that electrically active upper layer of our atmosphere, blocks or distorts certain low-frequency radio waves, which means there are parts of the radio spectrum that are extremely hard or impossible to study properly from the ground. Spacecraft can observe some of this, of course, but a radio observatory on the far side of the moon could combine the distance from Earth's interference with a stable surface and a natural shielding of the lunar body. It would be like finally turning off the kitchen extractor fan you forgot was roaring in the background of your thoughts. This is one reason the far side has long inspired dreams of radio telescopes. Not giant, shiny dishes necessarily, though those do look satisfyingly dramatic in concept art. Sometimes the vision is more delicate. Arrays of antennas spread across the surface, perhaps in a crater, perhaps across plains, quietly gathering signals from the cosmos that are nearly impossible to hear elsewhere. A place where the oldest, light-adjacent whispers of the universe might be studied in frequencies mostly hidden from Earth-based ears. A place where scientists could listen for clues about the early cosmos, solar activity, planetary magnetospheres, and all sorts of phenomena that radio waves carry more faithfully than visible light ever could. And the far side seems made for that role because its quiet is not artificial. No one has to build the shielding. The moon supplies it. You do not need a planetary scale wall because there is one already, gray and cratered and exquisitely indifferent. The same tidal locking that once made the far side mysterious now makes it scientifically precious. The hidden hemisphere is hidden not only from view, but, in a way, from broadcast. It is tucked behind a natural barrier, a geological hush. Of course, quiet never means absolutely perfect in a practical sense. Spacecraft in lunar orbit or relay satellites can introduce radioactivity. Future missions would need careful coordination if a protected radio astronomy zone were ever established. The sun itself is not exactly a shy source in radio wavelengths, and the universe beyond Earth has plenty to say. But those are not the same as the constant, messy closeness of human-made interference pouring from the planet below. The far side's gift is not total emptiness. It is selective peace. It removes the loudest nearby talker from the line of sight. That selective peace fits the far side's whole personality beautifully. This hidden hemisphere keeps turning away from Earth, and with that turning away comes more than visual privacy. It becomes a refuge from the planet's habits. On the near side, Earth would loom in the sky, a huge reminder of oceans, weather, traffic, old songs, space agencies, arguments, weddings, text messages, and someone somewhere definitely trying to connect a Bluetooth device that does not want to be found. On the far side, the sky contains none of that visually and much less of it electromagnetically. It is not anti-Earth. It is simply unoccupied by Earth. There is something soothing in the idea that the cosmos still has gradients of quiet. Not every place near home is equally saturated with us. There remains, just around the curve of our nearest celestial companion, a region where the moon can hold our signals at bay and let the wider universe come through more clearly. It feels almost moral, a reminder that listening requires shelter. You cannot hear subtle truths if loud, familiar things are always in the way. The far side understands that in stone. If you imagine a radio observatory there, it is easy to picture it in the same long lunar dawn you have already crossed, antennas standing low and spare against a brightening horizon. No atmosphere to flutter, no birds to land on them, no weather to complain about except the moon's delightfully unreasonable temperature swings. The instruments would wait through long days and longer nights, letting the hidden hemisphere do what it has always done: block Earth, face deep space, and keep still. It is such a simple arrangement and such a profound one. One half turned toward home, one half turned toward the rest of the universe. The far side listens outward. That outward listening also carries a faint emotional echo. Everyone knows the relief of stepping away from noise, of leaving a crowded room, of finding a hallway, a balcony, a parked car, or a dark kitchen at midnight where you can finally think without being edited by other people's urgency. The far side is that feeling, but on a celestial scale. The moon itself becomes your hallway. Its body takes the pressure of the noise. Behind it, you can finally hear the fainter things. The science is grand, but the image is gentle. A hemisphere with ancient craters and thicker crust, with long mornings and giant basins, also happens to be one of the best nearby places for radio silence. Not because it was designed for us, Not because the universe wanted to be accommodating for once. Simply because geometry and rock and orbital history arranged themselves in a way that produced a sanctuary. The far side does not know it is special. That somehow makes it more special. And so you linger there a little longer in the protected hush behind the moon, while Earth goes on transmitting to everything else and failing, for once, to reach you directly. The hidden hemisphere faces outward into deep time and deeper space, holding back the bright, loud planet behind it. In that stillness, you can begin to understand why the first glimpses of this world felt so uncanny when they finally arrived. Humanity had imagined the unseen side for ages, but when machines at last crossed over and sent back images, they were not bringing home a fantasy. They were revealing the appearance of a place that had been quietly listening all along. They were revealing the appearance of a place that had never needed an audience. And that may be why the first human-made glimpses of the far side feel so quietly haunting even now. For most of history, the hidden hemisphere existed as an idea more than an image. You could reason that it must be there, of course. You could understand the geometry, at least once someone explained tidal locking without making your eyes glaze over. You could even guess that it would be cratered and ancient because the moon had already shown enough of its habits on the near side. But knowing a thing must exist is not the same as seeing it. A closed door in a familiar house can still provoke the imagination far beyond what the actual room deserves. So picture the long stretch of human curiosity before any machine crossed that threshold. The moon had been studied by naked eye observers, then by telescopes, then by increasingly careful maps of the side facing Earth. Poets made it sentimental. Scientists made it measurable. Dreamers made it inhabited. The far side remained untouched by all of that direct seeing. It was the nearest unseen world, which is a wonderfully irritating category for human beings. We're not good at leaving nearby mysteries alone. We can tolerate distant unknowns because they feel politely unavailable. But something close and hidden becomes irresistible. And then, in the 20th century, machines became good enough, brave enough, and obedient enough to do what humans could not yet do in person. One of the great quiet revolutions of space exploration was that it replaced some of the oldest myths not with disappointment, but with sharper wonder. The far side did not turn out to be a magical kingdom, a glowing abyss, a cosmic filing cabinet, or anything else your more theatrical ancestors might have been tempted to sketch after 2 cups of wine and a suspiciously active imagination. It turned out to be real in a way that was better than fantasy. Cratered, rough, bright, ancient, and deeply itself. The milestone that changed everything came when a Soviet spacecraft, Luna 3, flew around the moon in 1959 and sent back the first images of the far side. The pictures were crude by modern standards, and calling them grainy is generous in the way people are generous about old family photographs where no one's face is fully visible, but everyone insists the emotional value is the point. Yet the emotional value was absolutely the point. For the first time in history, humanity was not inferring the hidden hemisphere. Humanity was seeing it. You can imagine the mood of that moment. Not just excitement, though there was plenty of that. More like the sensation of a map acquiring a coastline where there had only been blankness. The far side had moved from theoretical companion to observed terrain. The hidden face of the moon arrived not in cinematic perfection, but in imperfect transmission with contrast, blur, and limits that somehow made the achievement sweeter. Space exploration often begins that way, not with glossy revelation, but with stubborn fragments that prove a door has opened. And what those fragments showed was startling. The far side looked very different from the near side. It had far fewer of the broad, dark Maria that made the moon's Earth-facing hemisphere so familiar. Instead, it appeared heavily cratered, dominated by highlands, rougher and older in expression. This was not just a minor variation. It was a hemispheric difference large enough to reshape lunar science. The moon was not symmetrical in the simple visual way many might have expected. Its hidden face had its own geology, its own emphasis, its own long memory written more openly across the surface. There is something charmingly anticlimactic about the revelation, too, in the best possible sense. Humanity finally sees the hidden hemisphere of the moon and discovers not dragons, not glowing cities, not the celestial equivalent of someone having hidden all the good furniture upstairs. Just more moon. But more moon in a form no one standing on Earth had ever seen, and therefore a new kind of beauty. Sometimes the universe rewards your curiosity not by overturning reality, but by deepening it. The far side was not fantasy. It was evidence that reality had more texture than your myths. Luna 3's images were enough to transform the unseen into the seen, but they were only the beginning. Later missions refined the view, mapped more of the hemisphere, and corrected the early rough impressions with better data. Bit by bit, the far side became a place instead of a secret. More Soviet missions, American missions, orbiters, cameras, and later increasingly sophisticated lunar mapping efforts built on that first act of mechanical courage. The moon's hidden half stopped being blank space on the chart and became topography, composition, structure, history. That change sounds clinical when said quickly, but in the emotional history of knowledge, it is enormous. To see a place for the first time is always bigger than the technical quality of the first image. You can almost feel the strange innocence of those early glimpses. Today, images arrive in floods. High-resolution color mosaics, global elevation maps, zoomable data layers, process composites polished until every crater looks ready for a coffee table book about geologic solitude. But the first Farside images belong to an earlier style of revelation. They asked for patience. You had to look harder. You had to accept uncertainty. A basin might be only partly clear. A crater rim might emerge from blur more by understanding than by eyesight alone. It was discovery with static around the edges, and that somehow fits the far side perfectly. The moon had waited billions of years to show that face, and when it finally did, it did not pose. Their refusal to pose is one reason the early images still carry such power. They are not just records of surface features. They are records of a threshold crossed in human perception. Before them, far side of the moon meant hiddenness. After them, it meant geography of an unseen kind. Yes, but geography nonetheless. A place with names, structures, asymmetries, mysteries of crust and basins and radio quiet. A place that could be studied rather than merely imagined. Once that shift happens, the universe changes character. It becomes less symbolic and more intimate. Yet the symbolism never disappears entirely because humans are wonderfully unable to leave meaning alone. The far side remained a natural metaphor for mystery, privacy, isolation, the unshown self. If anything, the first images made that metaphor richer rather than weaker. The hidden hemisphere was not a blank void. It was a complicated, heavily scarred landscape. Ancient, bright, less smoothed by volcanism, home to giant structures like the South Pole, Aitken Basin, and turned away from Earth's constant gaze. The metaphor improved because the actual place had texture. There's also a sleepy sort of heroism in the machines that brought those first glimpses home. Early spacecraft were operating under constraints that now seem almost quaint, which is unfair because quaint is not usually how one describes sending metal and electronics across space and asking them to work perfectly around another world. Communication windows were limited. Imaging systems were primitive by current standards. Navigation demanded nerve and brilliance. Everything had to survive vibration, vacuum, radiation, timing, and the general tendency of space to punish optimism. And still, those machines swung around the moon, and looked where no human eye had looked. It is worth pausing over that kind of bravery, even if it belongs to circuits and commands rather than nerves and pulse. Machines inherit human courage in a very odd way. Someone designs them, tests them, sends them, And then the machines performed the part of the journey that bodies cannot yet do. Luna 3 was not dreaming of discovery, obviously. It was not feeling awe or whispering, "Good heavens, would you look at that?" But it carried human curiosity around the lunar curve and turned it into evidence. Sometimes that is enough to make a machine feel almost mythic. And those first looks did something else that mattered. They taught humanity that hidden does not mean opposite. The far side was different, yes, strikingly so, but it was still part of the same moon. The old phrase, dark side, had encouraged a dramatic misunderstanding, as if the unseen hemisphere must be some inversion of the familiar one, a lunar alter ego with secret eyeliner and unresolved issues. Instead, the far side was continuous with the moon's deeper history. Different crust, different volcanic expression, different visible terrain, but not a separate character. The first images did not reveal another world. They revealed the fuller truth of this one. That fuller truth invited new questions. Why fewer Maria? Why thicker crust? How old were these surfaces? What could giant basins tell us about the moon's interior? What kinds of missions might survive and work there? Once the hidden hemisphere became visible, curiosity did what curiosity always does when it is healthy and well-fed. It multiplied. One answer generated 10 more questions. One image generated a program of exploration. One glimpse of rough highlands and crater-choked plains became a new field of study, a new set of dreams, a new argument over where the next brave machine ought to go. You can sense the emotional transition in all of this. The far side moved from being a comforting mystery to being a knowable mystery. Not solved, never fully solved, because worlds are more patient than our explanations. But knowable enough to engage. Knowable enough to map. Knowable enough that one day, rather than merely photographing it from above, humanity would attempt the next delicate step, to land in that hidden wilderness itself, with all the challenges that isolation imposes when direct radio contact with Earth is impossible. So you hold for a moment in those first blurred images, those rough monochrome proofs that the unseen had texture after all. You imagine the engineers receiving them, the scientists studying them, the public absorbing them, and the moon itself remaining perfectly unbothered by the entire fuss. There's something very soothing in that combination. Human excitement, mechanical perseverance, ancient indifference, the far side finally seen, and still just sitting there under its long sunlight and long night, cratered and calm, as though it had always known that one day someone would come peeking around the edge. That calm, ancient indifference eventually met something new on the hidden hemisphere. Visitors that did not simply look from above, but touched down in the far side dust and tried, with very human persistence built into metal bodies, to work there anyway. And of course the far side, being the far side, did not make this easy. Landing on the moon is already an elaborate negotiation with gravity, fuel, terrain, timing, and the alarming fact that nothing up there cares whether your checklist is complete. Landing on the far side adds another insult. You cannot talk to Earth directly from the surface, because the moon itself is in the way. The hidden hemisphere is hidden operationally too. If you want to work there, you must find a way to whisper around a world. That requirement alone gives far-side exploration a special kind of elegance. A near-side lander can point an antenna home and have its conversation more straightforwardly, at least by lunar standards, which is a bit like saying one cliff is easier to climb because it has fewer knives in it. A far-side lander has no such convenience. It wakes up on terrain no human on Earth can see directly, under a sky with no Earth hanging above, and if it wants to report that it is alive, it needs help from something stationed elsewhere. It needs a relay. So before a robotic explorer could truly settle into the far-side wilderness, engineers had to solve the problem of communication in a way that feels beautifully fitting for the moon's hidden half. The answer was not to bully physics into behaving differently. Physics, as usual, declined to be bullied. The answer was to place a relay satellite where it could see both the far side and Earth, acting as a patient go-between. Not magic. Geometry. The whole story of the moon keeps returning to geometry, as if the universe would like you to know that elegance and stubbornness are secretly the same thing when practiced long enough. One of the most graceful examples of this came with China's Chang'e 4 mission. Before the lander and rover ever touched the far side, a relay satellite called Keiqiao was placed into a halo orbit around the Earth-Moon L2 region, a location beyond the moon where the gravitational dance of Earth and Moon allows a spacecraft to maintain a useful position with the right orbital choreography. Useful position sounds dry, but what it really means is that Keiqiao could look back toward Earth and also maintain sight of the far side where the lander would work. The hidden hemisphere got its own celestial switchboard operator. There is something almost tender in that arrangement. A far-side explorer cannot just call home. Home has to station a listener beyond the curve of the moon, someone patient enough to stand in the middle and repeat the messages. I am here. I landed. I am rolling a little. I found rocks. I survived the night. It turns the far side into not just a place of solitude, but a place where connection must be deliberately built. Nothing casual reaches it. When Chang'e 4 finally made the first successful soft landing on the far side of the moon in January 2019, it did more than score a technical first. It changed the emotional geography of the hidden hemisphere. The far side was no longer only mapped, photographed, and inferred from orbit. It had hosted an arrival. In Von Karman crater, within the vast South Pole, Aitken Basin you have already crossed, a lander settled into the dust with all the quiet drama lunar exploration prefers. No triumphant brass music in a vacuum. No dust cloud billowing theatrically in the wind, because the moon remains deeply committed to not having wind. Just descent, contact, and the beginning of a new relationship between a remote landscape and the machines humans send in their place. Beside the lander came the U-2 rover, which sounds cheerful and compact, and then proves itself worthy of the name by proceeding across one of the most isolated surfaces near Earth with a kind of calm mechanical determination that is hard not to admire. Rovers on the moon live by routines that are equal parts bravery and housekeeping. Wake when sunlight is available. Check systems. Communicate through the relay. Move carefully. Study the ground. Endure the brutal cycle of lunar day and night. Try not to die for reasons that would sound embarrassingly trivial if they were happening in your kitchen, such as dust, temperature extremes, will trouble, or a single component deciding it has fulfilled its emotional arc. What makes farside operations especially impressive is that every command, every bit of science, every health check depends on that communication architecture holding together. The lander talks to the relay. The relay talks to Earth. Earth replies. It is a conversation with an extra breath in the middle. That added distance and dependency do not make the mission impossible, but they do make it delicate. The hidden hemisphere never lets explorers forget where they are. Even success arrives with a layer of mediation. And still, perhaps because of that very mediation, the work there feels unusually serene. You can imagine the lander sitting in the stark light, its instruments studying local conditions, its cameras looking across low lunar horizons and cratered ground no human I could ever see directly without help. You can imagine the rover moving carefully over the regolith, leaving tracks that persist because there is no weather to erase them, pausing to inspect rocks and soil, while above it the black sky remains empty of Earth. Every packet of data comes home by way of a quiet companion station beyond the moon. It is exploration with an almost monastic rhythm. The engineering stubbornness behind this is one of the far side's loveliest human stories. Because really, what is a far side landing except a refusal to accept that hidden means unreachable? The moon says you cannot see this hemisphere directly from Earth. Engineers say, noted, we will place a communications relay in just the right orbit and come anyway. The moon says temperatures here are wildly inconvenient. Engineers say, yes, we have been reading the brochure. The moon says your solar power machines must survive long nights and then wake again. Engineers say, perhaps not gracefully, but we will try. This exchange has been going on for the entire space age, and it never stops being endearing. Chang'e 4 was not only an engineering first, it was also a scientific foothold. Instruments on the lander and rover examined local geology, surface materials, and the shallow subsurface, helping researchers better understand far-side terrain and the context of the South Pole, Aitken region. The details matter scientifically, but even at the level of pure feeling, the mission gave the far side something new. Presence. Not a passing flyby, not an orbital glance, a long stay. A machine waking and sleeping there, working there, aging there. The hidden hemisphere stopped being merely hidden. It became inhabited, however briefly and mechanically, by patient attention. And then there is the deliciously practical absurdity of lunar survival. During the long lunar day, solar panels can drink in energy and systems can operate in sunlight. During the long lunar night, temperatures plunge so severely that survival becomes a matter of insulation, heating, power budgeting, and luck tempered by excellent design. Every lunar explorer is, in some sense, a tiny stubborn house trying to keep itself warm on a world that offers no sympathy. On the far side, that challenge feels more intimate because of the communication relay. When night comes, the machines are not only cold, they are out there beyond the moon's shoulder, where even saying goodnight to Earth requires a third party. The far side's robotic visitors did not stop with one dramatic first. The success of Farside operations opened a path for later missions and more ambitious work connected to that hemisphere. In 2024, Chang'e 6 carried the story further by reaching the far side, landing in the South Pole, Aitken region, collecting samples, and returning them to Earth. That achievement layered something new onto the hidden wilderness. Not just presence, not just measurement, but retrieval. Material from the far side could now be studied in laboratories on Earth, bringing the hidden hemisphere home in a form more intimate than images or remote sensing alone. The moon kept its secret face for ages, then eventually allowed little sealed pieces of it to travel back across space for inspection under fluorescent lights, which is not glamorous, but science has always had a thing for the least glamorous possible room, where the most amazing truth is quietly sitting in a tray. Yet even with sample return and growing sophistication, the far side remains emotionally defined by distance. Every successful mission, there feels a little like threading a needle in another room using a mirror. You can do it, but only if every part of the setup has been thought through with almost unreasonable care. Relay assets, navigation, landing hazard avoidance, thermal design, timing through the lunar day-night cycle, rover mobility, communication windows, science planning, all of it must cooperate. The far side does not forgive sloppy ambition. It rewards patience and systems thinking, those less glamorous cousins of heroism that usually deserve more applause than they get. And maybe that is why robotic explorers suit the far side so well. They are patient by design. They do not get lonely in ways that keep them from functioning. They do not mind repetition. They can sit through long sunlight, long darkness, and long silences with no crisis of identity. Their courage is procedural. Their wonder belongs to the humans interpreting the data. Together, that makes a lovely partnership. Humans provide the yearning. Machines provide the endurance. The far side provides the test. So you imagine those landers and rovers out there still, or their tracks, or the memory of their work, preserved in the dust where weather never comes to tidy anything away. A relay satellite hangs in its careful path, listening and repeating. The hidden hemisphere receives these visitors without ceremony, letting them touch its crater ground, study its old rocks, survive what they can, fail when they must, and send their findings home by the long way around. It is exploration softened by distance, made more beautiful by inconvenience. And once machines have proven they can live and work in that hidden wilderness, your thoughts naturally begin drifting toward the places on the far side where the light grows even stranger, especially near the poles, where some craters scarcely see the sun at all, and the cold may preserve something precious for future explorers. That precious thing the cold may preserve is not some glittering lunar lake. Unfortunately, because the moon remains committed to elegance over convenience. What may be waiting in the far side polar regions is subtler, quieter, and somehow more enchanting for that very reason. Water ice, hidden in places where sunlight barely reaches or never reaches at all, tucked into crater floors and permanently shadowed pockets, so cold that molecules delivered long ago by comets, asteroids, the solar wind, or the slow migration of water across the lunar surface could survive for extraordinary lengths of time. The far side is already the moon's private face. Near the poles, that privacy deepens into deep freeze. You have to imagine the geometry carefully, because polar light on the moon is strange in a way that feels almost like a whispered secret between astronomy and topography. Near the lunar poles, the sun never climbs high in the sky the way it does at lower latitudes. It schemes low around the horizon, tracing shallow circles over the long lunar day. That means crater rims and local relief matter enormously. A slight rise can catch sunlight again and again. A deep depression can miss it almost entirely. Some ridges and high points receive unusually prolonged illumination, while some crater interiors stay in shadow for geological ages. The moon, which already stretched sunrise into an era, now starts dividing the landscape into tiny kingdoms of light and permanent night. Those permanently shadowed regions are among the coldest places in the solar system. Not because the far side is melodramatic, though it would have every right at this point, but because if sunlight never reaches a crater floor and there is no atmosphere to transport heat in any friendly way, temperatures can remain unbelievably low for vast spans of time. Cold there is not a passing condition. It is almost a form of storage, a molecular pause button. In such places, volatile substances that would vanish quickly from warmer, sunlit ground may linger. Water molecules, once delivered or created and then migrated into these traps, can become part of a quiet polar inventory. That possibility turns shadow into treasure. Not treasure in the pirate sense, sadly. No chest, no gold, no satisfyingly dramatic skeleton pointing at a map. More like a scientific and practical treasure, the kind that makes mission planners sit up a little straighter and researchers start using phrases like in situ resource utilization with the grave joy of people who know the future may depend on turning local materials into useful things. Water on the moon is important because water is never just water when humans are planning to stay somewhere. It is drinking water, yes, but it can also be split into oxygen for breathing and hydrogen for fuel. Every kilogram you do not need to launch from Earth is a small miracle of logistics. And because some of the most promising cold traps lie near the lunar poles, the far side polar regions become doubly interesting. They sit at the intersection of several lunar advantages you have already been circling: ancient terrain, unusual lighting conditions, proximity to vast structures like the South Pole, Aitken Basin, and on the far side, or near its edge, that precious radio quiet shielded from Earth's constant chatter. It is as if the moon, after ages of appearing simple from afar, reveals near the poles that it has been quietly preparing a portfolio. Here is deep cold. Here are long shadows. Here are old rocks. Here is a place to listen to the cosmos. Here is perhaps a supply closet for future explorers, though admittedly one kept at an absolutely unreasonable temperature. Of course, lunar ice is not expected to behave like the clean, gleaming blocks of a movie set. It may exist as grains mixed into regolith, as patches in shadowed soils, as frost in some microenvironments, or locked in complex distributions that vary from crater to crater. The moon is not obligated to package resources conveniently for species that only just learn to land there without panicking. Still, Evidence from orbital measurements and impact observations has made the presence of water-related materials at the poles one of the most important realities in modern lunar exploration. The exact amounts and accessibility vary. The details remain areas of active study, but the broad message is clear enough to reshape strategy. The poles matter, and when the poles matter, the far side gets pulled into a future that feels suddenly less abstract. It is one thing to admire the hidden hemisphere as a place of mystery, old craters, and radio silence. It is another to imagine actual infrastructure there, however delicate at first. Power systems on sunlit ridges, robotic prospectors descending into shadowed craters, communication relays keeping everyone in touch around the curve of the moon, science stations using the unique quiet of the far side to study the universe. Perhaps even crews one day working near polar regions where light and resource access can be balanced with maddening lunar ingenuity. The far side stops being merely a destination for visits and starts looking like a candidate for presence. Presence, naturally, will not be simple, because the moon has so far shown no intention of rewarding optimism that arrives without engineering. Permanently shadowed regions are cold enough to make ordinary hardship sound amateur. Sunlight can be scarce or angled in inconvenient ways. Terrain is rugged. Dust is abrasive and clingy, the kind of fine powder that seems to get everywhere because the moon believes in consistency. Communication still needs careful architecture, especially deeper on the far side. Human systems would have to balance illumination, thermal management, mobility, shielding, power storage, and all the delightful details of not dying on another world. But that is exactly what makes the prospect so compelling. The far side is difficult in ways that create meaningful design. You can picture it in slow layers. First, more robotic scouts, because robots are patient and do not write dramatic memoirs about their inconvenience. They map shadowed craters in greater detail. They sample soils. They confirm where ice is, how much there is, how deeply it sits, how difficult it would be to access. Other missions test power systems on ridges that see long sunlight. Relay satellites multiply or improve, building the communication skeleton for a more permanent relationship. Instruments listen to the radio universe from places Earth cannot easily spoil. Every success is small by the standards of fiction and huge by the standards of reality, which is almost always the better bargain. Then perhaps, over longer spans, human footprints. Not the near-side symbolism of a first landing performed for the whole planet to watch live, but something quieter and more infrastructural. Crews working at the edge of permanent shadow. Habitats tucked where temperature and power make the least impossible compromise. Excavation tools lifting icy regolith from darkness into processing units. Tanks filling slowly with water, oxygen, hydrogen. Astronomical instruments extending their sparse antenna lines into the far side hush. Human beings who have spent so much of history looking at the moon as a lantern or a symbol, finally learning how to use part of it as a workshop, a listening post, maybe one day a way station. There is poetry in the fact that the hidden hemisphere might help humanity not just understand the universe, but live more wisely within it. Radio quiet offers science. Polar ice offers possibility. Ancient basins offer geological archives. Long sunlight on certain high ridges offers power opportunities. Deep shadows offer preserved volatiles. The far side is not generous in the easy sense, but it is rich in the sense that matters most for exploration. It rewards patience with layered value. You do not go there because it is comfortable. You go because so many different futures overlap there. And still, even as those futures gather, the polar far side keeps its peculiar beauty. It is not all engineering diagrams and resource tables. The image remains hauntingly calm. A crater floor lying in darkness older than civilizations. A rim nearby, touched by low sunlight that circles but never climbs. A relay satellite holding its careful path beyond the moon. A lander parked in brightness. a rover edging toward a shadow line that may hide water older than memory. Above it all, a black sky free of the blue softness that makes earthly landscapes feel friendly. The moon's version of promise is severe, but it is promise nonetheless. That severity may be part of why the thought is so soothing. Human life is noisy with immediate needs, small frictions, accidental chaos, lost passwords, delayed messages, and appliances that break specifically when you're least emotionally available for it. The far side's polar future operates on another scale. It asks larger questions. Can a species learn to use local resources without wrecking wonder? Can science and survival share the same outpost? Can humans build quiet enough to hear the early universe while also building warmth enough to stay alive? The questions are practical, but they have a moral stillness to them. They ask not only what we can do there, but how carefully we can do it. Perhaps that is why the idea of future footsteps on the far side does not feel invasive in the imagination, at least not yet. It feels aspirational in a calmer key. Not flags and fanfare, so much as stewardship. Relay links, solar arrays, drills, spectrometers, radio antennas, careful routines under low polar light. A presence built with enough humility to notice that the place was magnificent before anyone arrived. The best future for the far side would not turn it into a noisy annex of Earth. It would let the hidden hemisphere remain itself, while inviting humans into a more disciplined version of curiosity. And discipline is exactly what the far side has been teaching all along. In Section 1, it corrected your myth about darkness. Then it stretched time with those absurdly long mornings. It showed you ancient scars, thick crust, giant basins, radio quiet, first glimpses and relay-dependent machines learning how to exist in its hidden wilderness. Now it adds one more layer. Beneath or within some of its coldest shadows may lie the simplest of substances in one of the most complicated settings, waiting to help turn a place of observation into a place of return. So you linger at the edge of one of those polar shadows, where sunlight grazes a rim but cannot descend, and you let the idea settle slowly. Ice where the sun does not reach. Future observatories where Earth's noise cannot intrude. Future footsteps measured not by conquest, but by patience. The hidden half of the moon has never needed to be dramatic, to be irresistible. It only needed to remain itself long enough for you to understand what it had been quietly offering all along. And once you have followed that offering all the way to the cold and the possible, it becomes impossible not to turn inward a little, because the far side has always done more than describe a place. It describes a way of keeping part of yourself out of direct view, and yet no less real for that. And that is where the far side stops being only a place and starts becoming a mirror, because after all the craters and the long sunrises and the thick crust and the radio hush and the relay satellites patiently repeating messages around the curve of a world, you begin to notice that what makes the hidden hemisphere so comforting is not merely its science. It is the fact that it gives you permission to believe in unseen things without turning them sinister. The far side of the moon is the most famous hidden face in the sky, and when you finally learn what it is actually like, the great surprise is not that it is stranger than you imagined. It is that it is gentler. You spend so much of life being asked to show your near side. The part that answers quickly. The part that faces the room. The part that could do daylight, schedules, polite competence, and the emotional equivalent of Maria. Those smoother dark planes that make a face easy to recognize from a distance. But everyone has a far side too. A more cratered half. An older-looking half. A place with rough, bright highlands where old impacts still show because they were never resurfaced into something simpler and more socially convenient. You do not need to be especially poetic to feel that truth. You only need to be honest for 10 seconds, which, granted, can be a very long time. The moon offers an oddly reassuring model for this. Its hidden hemisphere is not a failure of the visible one. It is not an error, not a defect, not some regrettable backstage mess to be apologized for under flattering lighting. It is part of the same world, shaped by the same history, lit by the same sun, governed by the same gravity, just revealed under different conditions. It has fewer of the broad, dark plains people turned into familiar stories. It has more exposed age, more preserved impact record, more silence. That does not make it lesser. If anything, it makes the moon more complete. There is deep comfort in that idea. You're allowed to have a half that is not facing outward. You are allowed to have regions that never get direct line of sight from the crowd. You are allowed to contain ancient basins, permanent shadows, radio quiet, weird geology, and a communication system that sometimes requires a relay because the message cannot travel straight through. Honestly, that last one may be the most human fact of all. Very little important communication in life happens directly. Most of it reaches another person by some orbital path through timing, trust, shared language, memory, humor, and the occasional miracle that someone finally understands what you meant 3 days later while brushing their teeth. The far side also teaches a more patient version of mystery. Human beings tend to panic around what they cannot immediately see. We fill blanks with fear, drama, or at the very least, a needlessly intense internal monologue. But the moon's hidden hemisphere has been sitting there all along, perfectly real, going through its own long mornings and long nights, requiring no myth to sustain it. Once you know that, mystery becomes less alarming. Something can be unseen and still orderly. It can be private and still sunlit. It can be quiet without being empty. That may be one reason so many people find the moon emotionally useful even when they are pretending to be above such things. It holds contradiction well. The near side faces home. The far side faces outward. One side carries the familiar face from storybooks and old songs. The other holds the thick crust, the bright highlands, the South Pole, Aitken Basin, the radio sanctuary, the polar shadows that make cradle ice. Together they make one body, not two identities fighting, not a mask and a truth in melodramatic opposition, just a single world with more than one mode of being. You can almost map parts of yourself onto it if you are in the mood for that kind of soft cosmic self-analysis, which tonight you probably are. There is the part of you that people know by habit, the tidally locked public self that keeps one face turned toward the daily earth of work, family, messages, responsibilities, and whatever fresh nonsense your calendar thought would be adorable this week. Then there's the part of you that faces deep space, the side not built for performance, the side where thoughts stay longer, where old marks remain visible, where the light moves slowly enough that you can tell what shape things really are. That side is not dark in the broken sense. It is only less observed, and being less observed can be a form of health. Not secrecy in the poisonous sense, not hiding from life, more like conservation, a place where not everything has to be translated immediately into words, reactions, or productivity. The far side of the moon does not rush to explain itself to Earth. It just continues its orbit, receives its sunlight, keeps its silence, and lets patient tools learn from it over time. There is wisdom in that posture. You do not owe the whole sky on your side all the time. Remember those long lunar dawns where sunrise takes days and shadows move so slowly in patience, eventually gives up and sits down. Remember the cratered highlands that looked rough at first and then became beautiful because age was allowed to remain legible. Remember the thick crust that made the far side harder to flood, harder to smooth over, more stubbornly itself. Remember the giant basin born in violence that now reads as grandeur. Remember the radio hush behind the moon, where Earth's endless chatter finally drops away. All of those are not just scientific facts. They are emotional instructions disguised as astronomy. Take your time. Keep some old marks. Do not let every interior thing get paved over. Let some silence exist between you and the noise. Trust that what is hidden is not automatically harmed. Even the permanently shadowed craters near the poles have something to say in this gentler register. Places that never receive direct sunlight can still preserve something precious. That is a lovely thought if handled carefully. Not every cold place in you is empty. Sometimes what survives, there's exactly what later makes new life or new work possible. Water ice on the moon is not romantic in itself. It is chemistry in a deep freeze. And yet it becomes future breath, future fuel, future return. So perhaps some quiet, preserved part of you, untouched for a long time, is not dead weight. Perhaps it is a resource your later self will need. The first images of the far side carry a lesson too. Humanity imagined that hidden half for centuries, then finally saw it, and discovered reality was not lesser than myth, only steadier. You can have the same experience with yourself. Parts of you may seem dramatic when they are unknown, but once truly seen, they are often simpler and kinder than fear predicted. Rough, yes. Complicated, yes. But real in a way that fantasy never is. Sometimes the hidden room in the house contains not monsters, but old furniture and a window facing a different direction. And then there are the relay satellites, patient little symbols of something else essential. Some distances are not failures. They just require architecture. If you cannot speak directly from your far side to someone else, that does not mean the message is impossible. It may need a relay, a friend, a notebook, time, a therapist, a walk, a piece of music, a quiet evening when your defenses are too tired to remain elegant. Communication does not have to be immediate to be true. The far side knows that. Every successful conversation from that hidden wilderness has gone the long way around. By now, the moon has become less like an object and more like a companion in thought, which is probably how it has lasted so successfully in human culture. It can handle projection without collapsing under it, but the science keeps the projection honest. The far side is not mystical because it rejects explanation. It is mystical because explanation turns out to be beautiful. Tidal locking is beautiful. Crustal asymmetry is beautiful. Ancient basins, radio shielding, polar cold traps, these are all beautiful not despite being factual, but because they are. The universe rarely needs embellishment. It mostly needs your attention. So you let the hidden hemisphere settle into its final shape in your mind. Not a dark side, but a far side. Not a place cut off from light, but a place cut off from easy view. Not a warning, but a reassurance that unseen things can still have order, rhythm, and worth. The moon keeps orbiting. One face toward home, one face toward depth. It does not choose between intimacy and mystery. It carries both. That is perhaps the most relaxing fact of all. And perhaps tonight, that is enough for you too. You do not need to explain every crater. You do not need to illuminate every shadow. You do not need to make your whole inner landscape legible at once. Some parts of you may still be in long lunar night. Some parts may be standing on a rim with sunlight skimming low across them. Some parts may be old, bright highlands where the record is still visible. Some parts may be quiet enough, finally, to hear faint truths beneath the radio noise of the day. The moon would not find any of this dramatic. It would simply continue being itself in the black, which is an excellent final example. The best forms of peace are not performance. They are structure, orbit, patience, a willingness to let reality be slower than fear, a confidence that what faces away is not lost. So the hidden half inside you does not need fixing tonight. It only needs the kind of regard we have been practicing here. Unhurried, curious, non-judging, a little amused by human overcomplication, and willing to admit that mystery can be restful when it is no longer mistaken for threat. The far side of the moon has been teaching that for billions of years without saying a word, which is frankly a level of composure most self-help books would kill for. And now the pace softens even more. You let the surface grow dimmer in your mind, not because it vanishes, but because distance becomes gentle. The bright highlands pale into silver-gray hush. The crater rims lose their sharp insistence. The giant basin rests like a deep, quiet memory. Somewhere near the poles, old shadow keeps its cold secrets without strain. Somewhere on a ridge, low sunlight lingers. Somewhere in the black above, a patient relay hangs in its careful path. And beyond all of it, the stars remain, clear and innumerable, needing nothing from you tonight. Your own thoughts can do the same now. They do not need to resolve themselves all at once. They can orbit. They can turn slowly. They can keep one side facing the warm, familiar world, and another turned toward the calm, dark distance where quieter truths live. There is no hurry to cross that distance, no demand to name every feature, just the steady comfort of knowing it is there, real and whole. The fan can murmur. The room can dim. The day can loosen its grip. You can rest without solving. Let the moon keep its hidden face. Let yourself keep yours too for now. Both are still touched by light, even when no one is looking. Both are still moving in faithful rhythms. Both belong completely to the same sky. And as the last of tonight's lunar glow fades softer and softer, you can feel the whole story settling down around you. The slow dawns, the old craters, the thick crust, the quiet behind the world, the brave little machines, the patient ice and shadow, the beautiful fact that what remains unseen is not therefore empty. It is only farther around the curve, waiting without anxiety, existing without performance, peaceful in its own time. So rest there. Rest where the noise cannot quite reach. Rest where mystery is gentle. Rest where even the far side of the moon, ancient and hidden and calm, has shown you that privacy is not darkness, silence is not loneliness, and distance is not the end of connection.